This is the 6th overall video in my series on doing inferential statistics with Google Sheets, mostly by finding p-values with simulations in a way that's hopefully a little bit more intuitive. In the previous video on this little mini-series on using paired numerical data, we took this 2018 June Pulse of the Nation survey and we looked at people's responses to the question of what they think the tax rate is for people making over $500,000 a year and what they think it should be. And we did what's called scrubbing the data, got rid of all the nonsensical responses. In this video, we're going to get set up for running our simulations to actually determine a p-value. This is a pretty complicated process, and Screencastify limits me to a 5-minute recording, and I can't fit it in that. So we're going to split it into two parts, and in this part, we're just going to do the setup. So over here, we've got what people think the average tax rate is, or the actual tax rate is. Here we have what they think it should be. And let's do the average of column A, and we want to go column A from cell 1 down to cell 440 equals average A2 colon A440. Did I say cell 1? I meant cell 2 because cell 1 is the heading. So people think the tax rate on people making more than $500,000 is 26.55%. They think it should be equals average column B, B2 colon B, 440. They think it should be about 28% for a difference of, this would be box H3 minus box H4. Equals H3 minus H4. People think that the tax rate should be about 1.5% higher than they think it actually is. Now here's the question, is that 1.5 a real difference? Do people actually think that? Or is that number simply an artifact of some degree of random chance? In other words, if we randomly assigned these different people to these two different columns, would we occasionally get a difference this big anyway? Therefore, we really can't attribute this difference to anything more than randomness. That's essentially the idea of testing for statistical significance. If randomly swapping around these two columns yields a difference at least this big about 5% of the time, then we say randomness is a perfectly good explanation for this difference, and we can't attribute it to anything other than that. If, on the other hand, we are unable to generate a difference this big due to randomness, then we conclude this is a real difference. People actually do think the tax rate should be a little bit higher than it is, probably about 1.5. In video 2, what I'm going to do is create a new column E and a new column F, which will be these two columns, but half the time the numbers will be switched. To set up for that over here, so these were our actual data, and this will be for our trials. I'm going to have this be the average of column E, which right now will be nothing, equals average E2 colon E440. And this will be the average of column F, equals average F2 colon F440. And this will be the difference between those two, equals, this is box J3 minus box J4. Equals J3 minus J4. Those are divided by 0 now, but as soon as I start typing numbers into here, numbers, not letters, try that again. Also, wrong column, try that again. As soon as I start typing numbers in here, these start showing up. So those formulas are good to go for video 2. All right, in the video immediately following this, which is video 3 of this series, video 7 overall, I'm going to show how to populate columns E and F with these same two columns, but the numbers half the time switched randomly.